says that we're going to integrate from 0 to pi over 2 of cosine of 1 over 3 theta d theta. Okay, so let's look at this. First of all, what we're going to do is notice that we actually have an outer function, the cosine, and an inner function, right? This 1 over 3 theta. So this is in the form 1 over 3 theta, like plus 0, right? So this kind of mirrors the kx plus b thing. So that means that because we have this this coefficient in front of our theta, we're going to need to flip it at some point. So if 1 over 3 is equal to k, equals k, then 1 over k should be equal to 3 over 1, which is just a 3. Okay, so we're going to need to add that factor of 3 in when we integrate. So let's do that. So we have, so if we integrate the outer function first, we just have a positive sign of whatever's inside. Okay, and then like I said, we have to add in that factor of 1 over k, which is equal to 3. So we have a 3 in front. All right, and now what we're going to do is basically just implement or put in our limits of integration. So 0 to pi over 2. Okay, so now let's just evaluate. So we have 3 times sine of 1 over 3, and theta is a pi over 2. So we have a pi over 2 there. Okay, so that's when we plugged in pi over 2, and then we're going to subtract when we plug in a 0. So that'll be 3 times sine of 1 over 3 times a 0. And so that's just going to end up being a 0 inside. Okay, so sine of 0. Alright, and then as we continue here, so then we have that we have a 3 times sine of pi over 6, right? 3 over 2 on the bottom makes a 6, and then minus a 3 times sine 0. And sine at 0 is just a 0, so we don't have to worry about that term at all. And we just have to worry about this sine pi over 6. So sine at pi over 6 is equal to a 1/2. So our final answer is going to be a positive 3 over 2.